A very good morning for my lecturer and my friends. I'm Chan Yi from Group A Leader, and my member is Pawan, Junket, and Jack. So, Junket, do you want to explain about EERD?
So I'm going to explain about our enhanced entity relationship diagram. First off, let's start with the staff entity. The staff entity has three big entities, which are the job contract, qualification, and work experience. The job contract contains the details of the type of contract issued to each staff. The qualification contains the details of where the staff graduated from and their highest certificate. The work experience entity contains the work experience of the staff from former workplaces. And each staff will only have one job contract, one qualification, and one work experience. Furthermore, there are many different types of staff, which are personnel officer, charge nurse, senior nurse, junior nurse, doctors, auxiliaries, special staff, and medical director. And the staff can only hold one position. The senior nurse, junior nurse, doctors, and auxiliaries are allocated into many wards, while there are many special staff allocated into many different wards. This special staff includes the consultants and physiotherapists. Then, one charge nurse will be responsible in overseeing one ward. Next, we move on to the next entity, which is the patient entity. When a patient is admitted into the hospital, the staff will contact the patient as of kin. Their details will be recorded down, and hence, the patient will have one vague entity, which is the patient next of kin. And one of these patient next of kin details will only belongs to one patient. And as for patient entity, there are two types of patient, which are patient in waiting list and patient in ward, and they cannot be both. Patient in ward will be staying in ward, and there can be more than one patient in ward staying in one ward. Then one patient will also be given one appointment at a time. Patient will be also given multiple treatment and medication. The same treatment can also be given to more than one patient. So for the next entity, which is the supply entity, there are three types of suppliers, which are the surgical supplier, non-surgical supplier, and pharmaceutical item supplier. And the suppliers can only supply one type of supply. So that's why it's a disjunctive conjunction here. And these pharmaceutical items will be used under many different wards. So that's it for our enhanced entity relationship diagram. So next we will move on to the relational schema.
Alright, so I'll be talking about our relational schema. So for the first table, which is called a staff table, we used all-in-one disjoint approach since we have 8 disjoint entities. So it is easier to just combine them together instead of splitting them into separate tables. Secondly, for our ward table, so for this table, we didn't take any approach since it does not contain any disjoint or overlapping entities. The same goes to the patient table also, since there is no disjoint or overlapping entities for this table. And so for the patient next of kin table, this table is a weak entity for the patient table, since it is a weak entity, so it's basically connected to the patient table. So like how Junket explained in the EERD. So this table also does not have any disjoint or overlapping entities, so there are no approach taken to this table too. So for the appointment table, so for this table, this an entity also, so main entity I mean. So there is for this table there is no approach taken also, since there is no disjoint or overlapping entity. Um, so for the supplier table, so for this table we used all-in-one disjoint approach so that we can separate the disjoint entities to subclass only. So for example, we separated pharmaceutical disjoint entity into pharmaceutical supplies. So this is an disjoint entity for the supplier. So that's why it's connected to the supplier, and there's a drug number which is connected to the patient treatment and medication, which I'll be talking in a while. So For the staff, like just now I said, we used all-in-one disjoint approach for the staff table. So for that staff, we have three weak entities for that staff table, which are staff job contract, staff qualification, and staff work experience. All these tables are connected to the staff table, and there are no any approaches taken to these tables. So for the patient treatment and medication table, it is also a normal table which is connected to the medication patient, which I'll be talking in a while, and it is connected to the patient table. So we created a medication patient table which says that which drug number is used for which patient. So after that, patient waiting list. So patient waiting list and the patient waiting list and the patient ward table are both the same. So basically, what they are the subclass approach. We use subclass approach to separate these two tables from the patient table. So and the last one is the special staff ward, which is a normal table also, but we separated it with staff and ward ID, staff number and ward ID. So what it says is that the details about which special staff is allocated to which ward and the staff number of the staff type. Yeah, it's connected to the staff table and the ward table. That's it for relational schema. So nextly for our UNF table. So we have total of 15 tables and mostly all of the tables are already normalized in UNF table, which means that after we did our ER diagram, our relational schema was already like normalized by itself. So basically, all the tables did not contain any data redundancy or whatsoever. So basically, our UNF tables are all complete with all values inserted in order, and these values are then transferred to the SQL. So all these are our UNF tables. So basically, everything is normalized already, and all the values are inserted. And so for the normalize, okay, uh, right. For the normalization process, like I said just now, mostly all the tables are already normalized by itself since there are no any multi-values or any data redundancy in most of the tables. But there is a table which has been normalized, which is appointment table. The rest all are already normalized by themselves. So for the appointment table, uh, so for the first normal form, the values are the same with the data dictionary one, but in the second normal form, the staff number has been split into another table, which the staff name and the room number depends on the staff number only. So for the third normal form, uh, it's the same as the second normal form since there are no transitive functional dependency of non-prime attribute on any candidate key. So that's it for our normalization part and our UNF part.
So after we insert everything of data, we can select all the information in the table. So we have 15 table. So let's come to first table. First table is a staff table. Staff table has a staff number, staff name, address, gender, phone number, DOB, which is date of birthday, national insurance number, current salary, salary scale, and staff type. In the word table, we have word ID, word name, phone number, location, total bed, staff number, and doctor number. Staff number is a foreign key as a word table. So patient table, we have patient ID, patient name, status, gender, DOB, which is date of birthday, date of register, address, and phone number. In the supplier table, we have supplier number, supplier name, address, phone number, fax number, and supplier type. In the pharmaceutical supplier, we have supplier table, drug number, drug name, drug dates, dosage, administration method, quantity stock, reorder level, and cost per unit. In the appointment table, we have appointment number, staff name, room number, appointment date, appointment time, and patient ID. In the staff job contract, we have staff number, staff type, staff contract type, and the hours worked. In the staff qualification table, we have staff number, qualification, date of qualification, and institute name. So let's come to another table. So it's a staff work experience table. So in this table, we have staff number, started date, finish date, in the position and the organization name. In the patient next of kin, we have patient ID, full name, relationship, address, and phone number. So let's move on to another table. It's a treatment and medication table. So in this table, we have drug number, drug name, drug unit, treatment type, treatment description, statement drug, and the treatment frequency, method of administration, start date, and finish date. In the medication table, medication patient table, we have drug number and patient ID. So in this table, drug number and the patient ID is a primary key as also is the foreign key. In the patient waiting list, we have patient ID, date place wait list, duration of stay, and the ward ID. So in patient ward table, we have patient ID, date place ward, bed ID, expected date, date leave, and the ward ID. And the last one is the special staff ward table. In this table, we have staff number, ward ID, and the special staff.
Alright, so starting with query 1. So this query basically just outputs all the patients that are in the waiting list. So currently we only have 2 in our database that is in the waiting list. So in the select, it basically selects out the patient ID, the date of admission, which is the same as the date placed in the wait list, their duration of stay, the ward ID, the patient's name, the type of disease that they are diagnosed with, the doctor ID and the doctor name, which is the doctor that is assigned to the patient, and the ward which they will be placed, which they will go into in future times. So yeah, this query is fairly simple. It's just selecting all the information that the question needs, and then from all the tables necessary, and the where function, the where clause just connects all the tables together to be able to output all the necessary information. So moving to query 2. Query 2 is to output the number of beds occupied for that certain ward. So we have 10 wards from ward 0 to 9. And how we calculate the number of beds occupied is we use this count bed ID. So how this works is, if we look on this table, so this is our patient ward table. So this is the patient ID. It has the patient ID, the date that they are placed in the ward, the bed ID, and then there's the ward ID. We don't really want to look at these 2 columns because that's not for our concern, not on what we are concerned about for query 2. Because query 2, what they want is they want to see the number of beds occupied in that ward. So the dates the dates on this table aren't really important. So we see that in this table we can see that the patient is assigned to what bed and is assigned to what ward. So from this, we take this information, we count the bed ID, because that means that the patient is already assigned to this bed and is assigned to this ward. So we count the bed ID and we check. So how the number of beds occupied, we put it as the number of beds occupied, because that would imply that the bed is already taken and is for which ward. So you may notice that this whole code is actually full of a select, and then there is union, and it continues select, union, select. The only difference between all of them is the patient ward ID, the ward ID for that patient. So basically we have all 10 wards that's here from 0 all the way to 9. So you might think that this code isn't automatic. Like if let's say the hospital adds new ward, and you have to go into the code and add more yourself. But think of it this way, we still think that this is still a viable approach to this solution, because a hospital, they won't just randomly add wards in a very short moment of time. If they were to add wards, I'm sure they will probably add it once in a while. So it's not like today they add 2 wards, tomorrow they add 3 wards, or maybe next week they'll add another 10 wards. So even if they do that, they do that, but it's gonna take time for the construction and everything. So there will be a, whether you will update, you need to update the code to add more wards. The time difference between the updates would be quite a while. So you won't be always having to need to update this code again and again. So we still think this is still viable, just because that you don't need to keep updating this again and again really often. So you still have to update it, but not so often. Okay, so query 3. Query 3 is really similar to query 2. The only difference is this part. So what query wants is they want the vacant beds. So in query 2, they showed the number of occupied beds. So what we did was, we take the total beds, which is actually 24. There are 24 beds in every ward. And then we minus the count for the patient ID, which is from this table, this patient ID. So from this table, you know that the patient ID is assigned to the bed ID and is assigned to what ward. So we do the same thing with the select and union with the ward behind, the ward ID behind, but we count the patient ID this time, and we have this minus operator. So the total bed, which is 24, minus the number of patients for that particular ward, and we put it as the vacant beds. And that's how you get this 23, 22, 23 all the way down. If you compare query 2 and query 3, you can see there's 1, 2, 1, then it goes all the way down 1. So basically take 24, minus 1, minus 2 for each of the wards, and then it will get this kind of output. Okay, so query 4. So this query, it outputs all the patients that are male and between the age 30 and 40, between ages 30 and 40. So how this works is in the select, so we have this whole calculation that is here as age. How it works is we use the date difference to calculate the difference between the dates. So we use the current date and the patient's date of birth to calculate the date difference. But the problem is the date difference function just returns the number of days between the two different dates. But as for age, we want to see the year, the difference of the year. So we had to add this, divide by 365, and so it will output the number of years in between. But there's another problem, because after you divide by 365, the age here would have decimal places, a lot more numbers behind. So what we had to do is we had to add the round function, and we round them to the nearest whole number, and then we put it as age, and that's how we get this age output. And then for the where, this whole part here is basically the same as the one in the select, that is to calculate the age. So basically what it says is where age is between 30, is more or equals to 30, and age is lesser equals to 40. And then here is the extra gender to filter out the gender for males only. And then there is the order by patient name. So it orders by this column and orders by gender in the ascending order. But technically it just goes or orders by the patient name because gender is the same. So from ascending order, as you can see, the names that start with A is at the top. All right, so query 5, what it does, it is it basically outputs the patients, which is the patient ID, who is handled by the doctors whose name starts with A or J. So currently in our database so far there is only this doctor whose name Albedo, whose name starts with A, but we don't have any doctors that start with J. So fairly simple also. This code is just to select these two, which is the patient and the doctor from these two tables, and then we link them together, and then we put the condition where the doctor name starts with the letter A or J, and then we order by the patient ID in descending order. And this is how you get this output.
In this query 6, this is our output. In this query, the list should be consist by drug ID, drug name, total of quantity per script, and number of patient count. So basically, we just select drug number as a drug ID, drug name. So we need to count the patient ID from medication patient table, and the last one is the total quantity per script. So in this, right, we can use that diff to count the starter date and finish date. So for example, we can see the treatment and medication table. So for example, right, in the drug number 6000, right, we can see that starter date is February 10, and the finish date is February 15. So we can use the that diff to count the start date and finish date minus treatment frequency and minus just now we are count the patient ID. So after we select everything, right, from which table we are select just now, and the where, right, where to patient ID, medication patient ID, and a medication patient drug number as a treatment and medication drug number to connect everything group by drug ID. So in the group by drug ID, right, so basically we just group by medication patient drug number and the treatment and medication drug number. So in this query 7, this is our output. So in this question, just list the information of medication appointment booked by patient. So it's nothing special. So we just select everything from patient ID, patient name, patient phone number, and treatment drug as reason of appointment. So staff number as doctor ID, and the staff name as doctor name. So address as a location, and the appointment date and appointment time. So from just now we are select which table. So we just from appointment, patient, treatment and medication, patient and medication patient table. So where the appointment ID equals to patient ID, so we are connecting, and the drug number and the medication patient drug number is a connect everything, and patient ID from medication patient table and the patient ID from medication appointment, so we are connect everything. So this is our output. So in last query 8, right, so we have two output. So let's move on to our code, SQL code. So in this question, just display the doctor ID, doctor name, patient ID, patient name, and number of patient booked by appointment. So basically we just select staff number as a doctor ID, staff name as the doctor name, patient ID, and the patient name. So from just now we are select which table is a staff, patient, and appointment. So where the appointment staff number equals to select any staff number from, so appointment group by this staff number. So we are having to count the staff number more than 3. So the question is say right, with more than 3 patients in a week. So in here, right, so we can say staff number to count more than 3, and also appointment table staff number in equals to staff number, so connect everything, and also patient ID to connect everything, and a week appointment date equals to select any week from appointment date. So from appointment table, so group by week, appointment date, and having count the every week in the more than appointment date more than 3. So this is our output. So we can see, right, we have doctor ID, doctor name, patient ID, and patient name. So we have missing one, right, is a number of patients we are booked by appointment. So we have to another result this, right. So we can say, right, so select from staff number as a doctor ID, staff name as a doctor name. So count the patient ID from count the patient ID. So where the staff number equals to staff number to connect everything, and appointment table patient ID equals to patient ID to connect everything, right. And also staff number equals to, so in this can say, right, select any staff number from appointment table group by this staff number to count the staff number more than 3, and also with the appointment date time equals to select any week's appointment date from appointment table. So group by week the appointment date, and also having count the week more than 3. So you can see the doctor ID we have 4, right, number of patient, and the patient name has Siti, Brian, Kumar, and Jonathan. So number of patient is a 4 result. So this is our output.
Hi, I'm Ho Jun Kiat and I'm from Group A. So what are my contributions to this assignment? My main contributions are in the making of the ERD diagram, the relational schema, the UNF tables, data dictionary, and the short description of the ERD. I also help out my group mates in the query questions when they ask for help. When they have difficulties, I will try to help them as much as I can, and when they are done with the queries, they will post the queries codes to us, to me and Pawan, and we will try to test the codes and see how we can improve on the code. So what did I learn from this assignment? I learned that constructing and maintaining a database at a large scale such as the hospital can be quite difficult and complicated. If you compare our database to the real database at the hospital, of course the real one will be way larger than the one that created in the assignment. So in the future, I will always be more open-minded to be more knowledgeable in this field, so that I can be better at designing a database. So what is the difficulties that I encountered, and what did I do to overcome it? So one of the main difficulties that I encountered is when making the ERD diagram. So when doing the assignment, I would feel like our ERD diagram has too much entities and attributes. So I'll often ask myself, like, do we need this, and do you need this entity, and do we need that attribute? Like, it will always be in my mind. So in the end, we overcame it by reading the question carefully and pinpointing the entities and attributes required in our database. Other than that, I'll say the assignment went quite smoothly, and there are some minor hiccups here and there, such as the query questions. But we overcame it by discussing with each other and find the best solution.
My name is Pawandip Singh. I'm from Group A. And my contribution towards this assignment was mostly on making sure that all the tables are correct in order for the queries to work. I helped on ER diagram and relational schema. This ER diagram and relational schema we all did together, since it was quite complicated actually. So I also did help on inserting all the values for the tables together with Junket. We also did data dictionary together, and I did a normalization part, so I had to make sure that all the tables are correctly normalized. I also did help my groupmates for the SQL queries, so when they had any issues, so basically actually we all helped each other whenever we had any problems. Okay, so what I learned from this assignment is that I learned the correct way on how to correctly normalize the tables. I did research it in online, like how the normal forms work, how does the data redundancy work, and stuff like that. So so I made sure that I learned like on how to reduce the data redundancy of the tables. Not only that, I also learned on how to be more cooperative with my group mates. That's the most important part. We always helped each other at all times. Like if any problems occurred, we just ask them to help us, and they will straight up help anytime. So the difficulties that I encountered was mostly on figuring out the question, the hospital management system basically. So these questions was really complicated actually. We had issues on making a proper ER diagram which is suitable according to the question given to us, but we had like problems with these disjoint values, so we weren't sure that if like disjoint values can be connected to another disjoint value. So we did research that, and then we did ask like other groups, our friends, and asked about their opinion, like if they have any ideas. So we did combine all those ideas, and then we made our own ER diagram, and it was a success actually. So yeah, that's it actually. We actually managed on making sure that the ER diagram is actually related to the hospital management system question that is given to us. Yeah. Thank you.
My name is Jack Tok Chuan Tong, and in this assignment I have mostly contributed in the SQL queries. I did contribute in the making of the ERD and the relational schema, but most of my contribution went into the SQL queries. What I learned from this assignment, I learned to use new functions in my queries, such as that date diff. So because some when I was doing the queries, I each and every query somehow posed some difficulty to me. So what I had to do, I had to go online. I learned all the new some of the new functions that we could use in our queries to answer the questions. So yeah, I learned about new functions for MySQL queries, and then other than just anything related to MySQL, other than that, I learned how to communicate better with my friends, with my teammates, and I learned on I learned that it's important to communicate and coordinate between my teammates on like delegation of our jobs in this assignment. And it's important that when we are doing the assignment, that we have to come together so that we know what's going on, like who's going to do what, and where are the changes, so that we are always up to date. Then it wouldn't cause so much more problems. The difficulties I encountered in this assignment was about the understanding the question. Because when I first read the question, it was that really long. The whole assignment document was like really long, and then I had to read from top to bottom, and then we had to know what the queries wanted, and then based on the queries, we need to like think about what needs to be in our data and what needs to be in our database. So especially from reading the case study about the hospital, I was like, there was just so many entities. I just got so confused when I first started, but we worked together, we put our ideas together, so it slowly became more and more clear, and it slowly made more sense to all of us, and slowly we were able to overcome this problem, just by communication, just by coordinating between us. And of course, we did ask for other people's advice, other friends for advice, to see what was their approach on their part of the assignment, to see if we could somehow integrate theirs with ours to make it into our own way of approaching solutions in our assignment. So other than those difficulties about understanding the question and all, was about coming out with the solutions for the queries. Like earlier on, I said about how I had to search for new functions. I had to learn about new functions because the current, like the ones that they teach in class, they may be sufficient, but you just need some extra things inside so that it can work much more better than expected, or at least work as expected. So how I overcome that was I had to go online, just go to different websites and see on new functions, and I had to learn on how they work. So sometimes I had to go to YouTube and view the videos and see people explain on like how like the date diff function works. I just basically learned most of the new things online, and that's how I overcame it. I overcome my problems. I had to go online, just search for answers.
So my name is Chan Yi, and I am from Group A leader. So what are my contribution in this assignment? So my contribution are making the ERD diagram, relational schema, and insert everything of value, and the last is the query question. So in this assignment, this is quite complicated actually. So we will help each other to complete all the table, inserting of value, and of course we will discuss together for the ERD. So, and of course, whenever I have a problem, right, my member will help me to solve my problem and make sure that the problem will solve it together. So what I learned to this assignment, so basically I learned about for the enhanced entity relationship diagram, such as the superclass and the subclass, and of course I learn more to communicate to my members. So that's it. Thank you.